In this video, we're going to look at piecewise functions. We're going to look at the definition of piecewise functions. We're going to talk about how to evaluate them algebraically and then how to evaluate them graphically. Piecewise functions are functions that are defined by pieces over specific domains. We've actually been working with them for a while when we were looking at stories from graphs, and now we're going to examine them in a more algebraic way. Functions assign inputs to outputs. Some functions have simple rules, such as f of x equals 2x. For every x, you're going to return 2x. Piecewise functions are more specific. So if x is less than 0, we're going to return 2 times x. But if x is 0 or greater, we're going to return x to the second power. That's a piecewise function where it's defined for different pieces of what x is. You're going to use a different rule. Here's what they look like graphically. This function is constant on the interval from -9 to -2, and then it jumps up to this piece and is constant on a new interval for x from -2 to 4, and then it jumps down to -2 on the interval from 4 to 9. So it says y is h of x. So h of x equals, and then for a piecewise function, a lot of times you see brackets like this. From -9 to -2, it's -9. And so that's when x is between -9, including -9, because that's a filled in circle, to -2, but not including -2. If it's -2, if our x is -2, we're going to return this function because -2 is not included here, but it is included up here. So for this function, it's always 7 between -2 and 4, including -2, but not including 4. And then between 4 and 9, it's -2. Not including 4 and not including 9. So if I say, what is h of 0? You're going to look here and go, okay, 0 is between -2 and 4, so that is 7. And I can see that on the graph too. If I say x is 4, oops, this should be -4. This should be +4 right there, my bad. You all were screaming that at the video, weren't you? If I say x is 4, this function is actually undefined because it's not this one and it's not this one, and there's no other definition for 4, so that's actually undefined. As if anything bigger than 9 is undefined and anything smaller than -9 is undefined. The previous function we had defined graphically, and this is algebraically, is where you only have an equation. It says evaluate h of x for this piecewise defined function. So let's say it's h of 3 that we're trying to find. So remember, this means I'm just going to plug it into the h function. I'm going to plug 3 in, but which piece do you use? Do you use the top piece, the bottom piece, both pieces? Well, it's 3. So it's defined as we're going to use this one because 3 is bigger than 0. Anything less than or equal to 0, we're going to use this one. So I'm just going to put 3 where the x is, and the answer is 11. If it was h of -3, I would use this one because this one is for when x is less than or equal to 0. So I'm just going to rewrite the function, substituting -3 in the place of x. And then 7 times -3 is -21. Divided by 3 is -7. Minus 1 is -8. So h of 3 is 11, negative 3 is negative 8, and let's do one more. Let's do h of 0, because that's the turning point between using this one and this one. And we're actually going to use the top one because this is x is less than or equal to 0. So this would be the closed dot one if we're thinking graphically. So 7/3 times 0 minus 1. This becomes 0. 0 minus 1 is negative 1. So that's how you evaluate them algebraically. And then let's look graphically one more time. Okay, so we have a graph here. We don't know the rule for this line and this line, but we can figure out these just by looking at the graph. So f of negative 4, so we go to where x is negative 4, and we go down to the graph. This point right here is negative 4, comma, negative 8. I can tell that because of right here. So f of negative 4 is negative 8. F of 0, here's where 0 is. I'm not going to use this piece because it's open. I'm going to use this piece. So this point is 0, negative 4. This point right here. So when I put 0 in the function, I get negative 4 out. I'm going to erase that so that I can do the next one. F of 2, so here's 2. Notice there's no dot there, but because there's a line there, I know there is a point. It's just not marked. So 2, negative 4. And then 8 is actually, there's no output for 8. So this is actually undefined by this piecewise function. Hopefully you have a little bit better understanding now of piecewise functions.